Students, we are going to discuss about some basic concepts of chemistry, one of the important chapter in physical chemistry, because the terms mole concept we are using almost all lessons in physical chemistry. Okay, so in this chapter we have mole concept, percentage composition, empirical formula, molecular formula, and stoichiometry and limiting reagents, and concentration terms will be there. Okay, so we will go one by one topic. What are the important concepts here? Okay, first we will start in mole concept. In mole concept, we have to find number of moles. Number of moles, what is the formula we have? Number of moles, we have formula N equal to given mass by molar mass, number of particles by Avogadro number, and volumetric STP by molar volume. Okay, we know that molar mass we can able to find based on the compound. Avogadro number value we already know that 6.023 into 10 power 23, and molar volume equal to 22.4 liter or 22,400 ml. Okay, so these are basic fundamental formulas related to mole concept, and here questions will be asking which have more amount of substance and which have more number of atoms, particles, molecules, electrons. What is the volume at ST? Okay, so first derived formulas we will check it. So mass we want to find, mass of substance. Then what you have to use? This is number of mass, molar mass. So N into molar mass. This will give you the mass of substance. Similarly, you want to find molar mass of unknown substance. Then you can able to find mass by number of moles. So this, by using first formula, we can derive mass and molar mass formulas. Okay. And third one, we are going to find number of particles. Generally, number of particles N will be equal to N into Avogadro number. N into Avogadro number we are using. Okay. So here our questions will be coming related to here. Number of molecules, we have same formula equal to N into Avogadro number. And second one, number of atoms, means how many atoms will be present in a molecule, that is we are calling this atomicity, into N into Avogadro. Okay, and number of electrons, protons, neutrons or ions they are asking. So number of electron or proton or neutron or ions in one molecule, in a molecule or ion, into how many that kind of molecules are there. So that will be give information about number of particles related to this. And these are the formulas we are using finding molecules, atoms and other particles. Okay, and another formula we have this one, volume at ST is equal to number of moles into molar volume we are using. So these are derived formulas. Based on the question also we will ask questions. And another small things we have to keep in mind. Okay, this number of moles related to the element they called gram atoms also, and related to the molecules, gram molecules. So it is gram atoms, gram molecules, it is nothing but number of moles only. That point you have to careful. Okay, and next one, it can also ask minimum molecular weight. So this is also some important model question. Minimum molecular weight asking questions are there, means at least 1 gram atom of element present. So this is the key point for the solving question. Suppose like in compound 8% of sulfur is present. So what is the minimum molecular weight? They are asking. So in this case, 8 grams will be present in 100 grams of substance. At least 1 gram atom. Gram atom means what? 1 mole. 1 mole means sulfur 32. 32 means how much? So cross multiply. And you will get it how much? 400 grams per mole. So the minimum molecular weight of substance is 400 grams per mole. So this is the way we can do it. And also we should know these formulas, that is average atomic weight will be sum over Ai xi by sum over xi. Okay, here A will be atomic masses of each isotope and X is the abundance. Okay, like you are taking carbon will be have different isotopes, hydrogen will have different isotopes. So each isotope, what is the atomic mass, what is the that particular isotope, what is the abundance, like that you can find. And also you can use average molecular weight. How we can able to find average molecular weight? Say sum over M1 N1, so Mi Ni by sum over Na. Okay, so here we are mixing gases. So what is the average molecular weight means? Each gas, what is the molecular weight? How many moles of the substance will be there? Or we can also use the formula sum over MiXi. Here X is related to the mole fraction, not abundance, mole fraction. Okay, so these are one set of formulas required for the mole concept. Okay, so next topic is, what is the next topic? Percentage composition. So percentage composition case, what we are basically finding, percentage composition case, we are finding what is the percentage of each element in the compound. Okay, so that's why we are using the formula percentage of element formula. So total mass of element in total mass of element by molar mass into 100. Okay, so if you take example simply, water is there means what is the percentage of oxygen? Means one oxygen is there 16 grams, total 18 grams into 100. So it is 88.89%. Like that we can able to find percentage of elements. Suppose we are finding similarly hydrogen, then this particular water have composition, percentage of oxygen is this much and percentage of hydrogen is this much. Like that we can able to find percentage composition. Okay. Next concept is empirical formula, molecular formula. Empirical formula gives the simplest ratio of atoms and molecular formula gives the exact number of atoms. Suppose if you are taking acetic acid, what is the chemical formula? CH3COOH. Okay. Now you observe 2 carbons and how many hydrogens are there? 4 hydrogens and 2 oxygens are present. So exactly 2 carbons, 4 hydrogens, 2 oxygens. So it is the exact number of atoms it is given. So this is related to molecular formula. Okay. And if you are taking the simplest ratio of atom, 2:4:2 means that is a 1:2:1. Then CH2O. This gives the information about empirical formula. The simplest ratio of atoms give the information about empirical formula. So what is the relation between the empirical formula, mass we are knowing. After getting empirical formula, we will get the empirical formula mass. Then molecular formula equal to empirical formula into X. Okay. So here X value, how we can find? Molecular weight by empirical formula weight, or if they given vapor density of substance, 2 into vapor density by empirical formula weight. By using this X we can find. So how we can find empirical formula? Let's take one simple example. Percentage of carbon is 80 is given. percentage of hydrogen is given 20, then how you can find empirical formula? Okay, so it is 80%. First we have to find number of moles of element, then relative number of moles, then simplest ratio you have to find out. That will be give the empirical information about empirical formula. Okay, suppose n carbon and hydrogen you have. So 80 by 12, it is 6.67. This is 20 by 1. It is a 20. So we got number of moles. Relative number of moles, we have to take, observe this number of moles, which is the lowest one you have to take and divide both the values. Then what you are getting? This is 1 and 20 by 6.67 means it is also around 3 you are getting. So the simplest ratio is there, 1:3. So carbon and hydrogen ratio 1:3. That empirical formula will be CH3. Like that we can able to find out. Okay. And if you, from this empirical formula mass will be how much? 1 carbon, 3 hydrogens, 50. You are getting. Okay. And if they are given in problem molecular weight, suppose molecular weight is 30, then we can able to find x value is equal 30 by 50 is 2. So molecular formula that time you can get, what you will get? CH3 2 times. So C2H6 ethane you are getting. So like this we have to find the empirical formula and molecular formula concept. It will be give the simplest ratio of atoms, and this will give the exact number of atoms. The relation is molecular weight by empirical formula weight, or 2 into vapor density by empirical formula weight. So first you have to find number of moles, relative number of moles, finally you have to find the relative simplest ratio of atoms. Then that will give the information about empirical formula. By using that we are finding empirical formula mass and x value we are finding and substituting this, we are getting the molecular formula. Okay. Next we are going to discuss about which one? Stoichiometry. Okay, stoichiometry problems are basically 2 types will be there. One is we are required amount exactly we are taking. One is one of the reactant we are taking excess, one will be less, like that, limiting reagent concept. So first stoichiometric problems you want to do means, what is the first step you have to do? First you have to write balanced equation. Balanced equation you have to write. You have to first write balanced equation. And second, that stoichiometric coefficients considered as a number of moles. Stoichiometric coefficients considered as a number of moles. We know that this 1 mole equivalent to what? It is equivalent to molar mass. It is equivalent to 6.022 into 10 power or 23 into 10 power 23 particles or 22.4 liter at ST for the gases. Okay, so this information we will get it. And the next one, then based on given data, based on information given, you have to solve the problem. Based on the information, you have to solve the problem. Okay, so that is a basic concept we have to use, write the balanced equation, and stoichiometric coefficients considered as a number of moles. 1 mole equal to molar mass or 6.023 into 10 power 23 particles, 22.4 liter at STP. Based on info given in the problem, solve the question. Okay, so that is a one we have to do it. Okay, here few reactions important. Okay, one is combustion reaction. CXHY is a formula. It will be react with the X plus Y by 4 O2 and giving the X CO2 plus Y by 2 H2. So this is the will be given. Suppose we want to find empirical formula of the hydrocarbon, then this x is to y you have to find x is to y. So x is to y will be give the information about this number of moles of carbon dioxide. Okay, this is the number of moles of water will be y by 2. From this y, what you will get it y equal to 2 into number of moles of water. So you can also get the empirical formula by using this concept x is to y is equal to NCO2 by 2H2. Okay, another important thing, combustion reaction case, we using oxygen. Okay, so oxygen present almost 20% in air, means out of 5 parts of air, 1 part will be oxygen. Okay, so that's why volume of oxygen required you can find from the equation. Volume of air means it is 5 times of volume of oxygen. Okay, so that is also important formula we have to keep in mind. Another important one, some reactions will be used, sodium bicarbonate like that. They will ask what happens if it is decomposed. Heat. It will give Na2, CO3, water and carbon dioxide. Okay. So in this case, this is the water and carbon dioxide is eliminated, and this residual substance will be present. Based on the question also will be asked. Okay. And one more important one, carbon dioxide react with the charcoal core carbon and form the carbon monoxide. But carbon monoxide with no reaction will be takes place with the charcoal. So this base question in a given compound, they are carbon monoxide is there, carbon dioxide is there, treated with carbon or coke. Then what happens? Like the questions will be asked. So this is also important one. And the next important one, this oxidation. Carbon monoxide undergoes oxidation. Okay, and this carbon dioxide, no oxidation will be takes place. So like this, few points will be important. Combustion is very very important. Like you have the volume of air, volume of oxygen. That differentiation you should know. And this sodium bicarbonate decomposition, and also one more, silver carbonate decomposition also. It will give 2H, and carbon dioxide you will get it, and also oxygen you will get it. So these few important reactions you have to know. So based on that they will ask questions. So stoichiometry, if it is anything excess is given, suppose here 10 grams of this compound is reacted with the excess of this compound, how much carbon dioxide will be formed? So with this, which is excess, you don't need to tell. So by applying the mole concept, we can directly solve by eliminating or by avoiding or that excess concept, excess amount. Okay, so that is the stoichiometric part and some important reactions. And the next one, limiting reagent. This is a very important one. This one we will go through one question, then you can easily understand. Okay, so generally when we are using 2 or more reactants and one reactant is lesser amount, then what happens? It completely consumed in the reaction. Lesser amount which is there, that is completely consumed in the reaction. And so after the completion of that reagent, the reaction further proceed, does not proceed because one of the reactant is exhausted. So in that case, what we are doing? We are applying the limiting reagent concept in that type of problems. Okay, and always a product is decided by or limited by one of the reactant which is lesser amount or which is completely consumed in the reaction, that we are calling as a limiting reagent. What is the limiting reagent? So the reactant which is completely consumed in the reaction and limit the product formation, that is we are calling as a limiting reagent. Other reagent we are calling as a excessive reagent. Okay, so same concept we are applying. So here 4 types of questions will be asked. What type of question? What is the limiting reagent? What is the excessive reagent? How many moles of product will be formed? amount of product will be formed, and how much left excess, that excessive reagent, okay, and total volume at the end. So this type of questions they are asking generally: what is the limiting reagent? What is the excessive reagent? How much product formation will be takes place? How much excessive reagent left excess after the reaction? And total volume at the end. Okay. So one simple example will solve the problem. Suppose I am taking H2O2 is giving the 2H2. It is a simple one. From equation, what is the information we are giving? 2 moles react with the 1 mole and with the 2 molar substance. Right? Now, in problem, they will give maybe this is the 3 mole or this is the 2 mole. So, like that, they give 3 mole, 2 mole, or they will give in terms of mass. This is the 3 mole means 6 grams, this is the 2 mole means 64 grams. Like that, they will give the information. By using that, what we have to find, which is limiting reagent, or how much product formation will be takes place. Okay. So first, if I am checking this one, okay, you observe that 2 mole required 1 mole. Then 3 mole required how much? We required only 1.5 mole only required. Half to 1 means 3 means 1.5. But how much we have? 2 mole means we require 1.5, but we have 2. So this is excess is there. This is an excessive reagent. This is then limiting reagent. Okay, now we identify what is the limiting reagent, what is the excessive reagent. You can say with respect to oxygen also, 1 required 2, 2 required 4, but we have 3, so it is less than what is there. Now product formation will be always takes place with respect to limiting reagent. So here which one is the limiting reagent? Hydrogen. So hydrogen 2 moles will be give 2 moles. Now 3 moles will be give how much? 3 molar. What? So this is the product formation. So we got limiting reagent, product formation. So how much excess will be there? Okay, how much excess will be present? So we know that this limiting reactor are formed. If take these 3 moles completely react because it is a limiting reagent, nothing will be there. In that 1.5 mole reactor, 0.5 mole excess will be there. And how much product will be formed? 2 moles. 2 moles means 3 moles. It will be give 3. So after reaction, we got excessive reagent present how much? 0.5 mole. So left excess 0.5 mole. Total volume excess volume at the end. Okay. So 3.5 mole will be present. Suppose if it is at STP means it is a 3.5 into 22.4 liters will be present at the end. Or how much water will become is 3 moles. Okay, 3 into 22.4 liter at STP. Only how much excess of oxygen will be there means 0.5 into 22.4 liters. So like that we can able to solve the questions related to limiting reagent concept. Okay, and the next one is the limiting reagent concept. Okay, and the next we are going to discuss about concentration terms. Okay, so basically we are going to discuss important formulas. Okay, first one I am coming this side. First, weight percentage. Weight by weight percentage. This is a simple one. Okay, it is give the weight of solute by weight of solution into 100. Percentage means per 100 ml how much. Same way, this is weight by volume percentage. Okay, so weight of solute by volume of solution into 100. So this is a weight by volume percentage. And third one is volume by volume percentage. So volume of solute by volume of solution into 100. So this is generally used in a perfume's case. Okay, 99% alcohol means 1% that perfume will be there. It may be aldehyde or any substance. Weight by volume, suspensions case they will use. Weight by weight, impure substance case they will use. Okay. And also important one, ppm, parts per million. Okay. So how we can find number of ppm? Is equal to how many parts of solute by total parts of solution into 10 power 6. That will be given ppm. Okay, parts per million. This one will be used for when solute is very less amount is present. Generally, degree of hardness or hardness of water we are finding, that ppm will be we are using. Okay. And next, mole fraction. Mole fraction. So mole fraction case, how we can find mole fraction? Okay. If you're taking substance A and B, two substances are there. If moles, Na moles will be there, this one Nb moles will be present. Okay, Na moles, Nb moles will be present. Then what happens? Total number of moles is how much? Na plus Nb. So mole fraction means mole fraction of A means number of moles of A and total. Mole fraction of B means number of moles of B by N total. And we know that some of the mole fractions always equal to 1. Like always percentages will be equal to 100. Like moles fractions will be equal to 1. So that is a mole fraction we are using. And the next one, we are using the concept molarity. Okay. Generally molarity represented with a capital M. Okay. And units will be mole per liter. So basic formula for this one, number of molarity will be equal to number of moles by volume in liter, or number of moles by volume if it is milliliter into 1000 we are using. Okay. And we already know number of moles is equal to mass by molar mass. So mass by molar weight into 1000 by V in ml. We can use that formula. These are just fundamental formulas. Basically, questions will become in a different way. So molarity, they will give weight percentage, weight by weight percentage and density. So in that case, we can use this formula. Okay, this weight by weight percentage sometimes called a purity, and this density per liquids they will called as specific gravity. Okay, like STSO4 they will called as a specific gravity will become. And sometimes weight by volume percentage they will give. Weight by volume percentage into 10 by molecular weight. Okay. And sometimes they will give strength. Strength in gram per liter they will give. So in that case by molecular weight will be given molarity. Okay. So these are different formulas related to molarity. Okay. So when you are doing dilution, dilution means number of moles remains constant. Number of moles remains constant will be there. So number of moles means N will be constant. So M into V will be constant, will be present. Okay. So M1 V1 equal to M2 V2. This formula we use for dilution. Okay. And this how much water will be added means, okay, V2 minus V1. The V2 minus V1 will give the information about how much water will be added. So these are molarity related formulas we know. Okay. So weight by weight percentage, weight by volume, volume by volume, number of ppm, and mole fraction and molarity. Okay. And the next concept we are going, which important one, molarity. This molarity is represented with a small m. Okay. So here molarity case, molarity is equal to number of moles by weight of solvent in kg. So there will be weight of solution and there will be volume of solution, here weight of solvent. Same similar formulas will be there, and if you are taking in grams, weight of solvent in grams into 1000 will become, or weight by molar weight into 1000 by weight of solvent in grams. We will get it. Okay. Second one. Okay. This is the first set of formulas. Here important molarity relation. Okay. So they ask molarity relation is molarity. We can find molarity by using formula molarity into 1000 by density into 1000 into molecular weight of substance into molarity. This is related to solute. Okay. So this is the molarity relation. Same way, another important one, molarity and mole fraction of solute. Molarity and mole fraction of solute. So XB we can find m by m plus 1000 by molecular weight of solvent. Water means 80. Okay. Or you want to find molarity means XB by 1 minus XB into 1000 by molecular weight of solvent. So these two relations are very important in case of examination. Molarity case, molarity relation, molarity mole fraction of solute relation. And we want to find mole fraction of solvent means 1 minus x, so that we can easily find out. So this is the one concentration terms. Yes, and before going normality term, we will discuss about valency factor first. Okay, valency factor also called as the M factor. Okay, how we can find? Okay, so valency factor, if you take elements, it will be, valency factor will be equal to valency of substance. Suppose aluminium, valency will be 3, zinc 2, and chlorine 1. So like that will be comes. Okay. So elements case valency will become. For ions, valency factor will be equal to charge on ion. Suppose Cl minus is there, that minus 1 is the charge. So magnitude of charge we have to take. We have to take magnitude of charge. Okay. So Ca2 plus, the valency factor 2. O2 minus, valency factor 2, like that. And the next one for salts, valency factor will be total magnitude of charge on cation or anion. Like you have Al2SO4, that is. Dissociate and give 2 Al3 plus and 3 SO4, 2 minus. Here total charge 2 into plus 3 means magnitude 6 and 3 into minus 2. So its magnitude 6. So valency factor for this one is 6. You have to either take cation or anion. And the next one for acids. Acids case, it is also called as the basicity. Valency factor also called as the basicity. And we can find number of replaceable hydrogen atoms. Okay. So example, you have HCl, 1 replaceable hydrogen, H2SO4, 2 replaceable hydrogen, S3, PO4, 3 replaceable hydrogens. So replaceable hydrogens will be given. And for oxo acids, number of OH groups. Okay. So oxo acid case, number of OH groups. Let you take phosphorus S3, PO4, P double bond OH, OH and OH. So 3 OH groups, valency factor or basicity will be 3. And S3PO 3, P double bond OH, OH, H. So 2 OH groups, so 2. And if another substance S3PO2, So in this case, 1 OH. So this all hydrogens may or may not be replaceable. Okay. So in oxo acids case, number of OH groups will be indicated as 1. If chemical reactions are going, means number of hydrogen atoms replaced. Give the information about valence factor or basicity. Okay. Basis case also they are using same. We are calling as acidity. Okay, valence factor is called as acidity. Here number of OH groups in base or number of OH groups replaced in a chemical reaction. Chemical reaction. So this will be the basis related valency factor. And finally we have valency factor for redox reactions. That will be redox reactions case. We use valency factor. How we can find number of electrons transferred by number of moles. This formula will be useful for redox titrations case. Okay, so that N factor for redox reactions separately we will discuss in the part of where in our redox concepts. Okay, so this is way of finding for elements. It is the valency. For ions, magnitude of charge. Salts, total magnitude of charge on cation or anion. Acids, number of replaceable hydrogen atoms or number of OH groups in oxo acids. And bases, number of OH groups in a base. Okay, like magnesium hydroxide, MgOH twice. Basicity will be, acidity will be 2, like that. Okay, so in that way we can able to find valency factor. So once we know the valency factor, what we can able to find equivalent weight. So equivalent weight is equal molecular weight by valency factor. Molecular weight by valency factor. So if you know the valency factor, we can able to find out the equivalent weight. For example, if you take aluminium, means 27 by valency 3. So it is a 9. If it is sulfate ion, okay. So 96 by charge is 2. Okay, 48. So like that we can able to find. Okay, HCl, H2SO4, like that we can able to find the equivalent weights. Okay. So once we know the equivalent weight, we can able to use the now concept normality. Normality is a important concept related to the titrations. Okay, and related to the redox titrations, and when doing a dilution case also we are using the normality concept. So normality is similar formula. We have like molarity, but here number of gram equivalents, number of gram equivalents by volume in liter. So how you can find number of gram equivalents? So number of gram equivalents is number of mass by equivalent weight. That will give the number of mass. So here we can write weight by equivalent weight into 1000 by volume in a minute. Similar to the molarity formula, but there will be molecular weight or molar mass we are using, here equivalent mass we are using. Okay. Same if they are given weight percentage, weight by weight percentage into density into 10 by molecular weight. If they are given weight by volume percentage into 10 by molecular weight. If they are given strength, here molecular weight, equivalent weight you will get. Strength means gram per liter, means you will get equivalent weight. Okay. And what is the relation between normality and molarity? That is also important. So normality is equal to valency factor into molarity. This is an important one. During dilution, N1 V1 equal to N2 V2. Okay. So dilution also same concept. N1 V1 equal to N2 V2, and V2 minus V1 give the information volume of water added. So this is the normality related one, but it is very useful in finding pH calculations and titrations related. So I will write that also, important one. What is the first? Neutralization. Neutralization case, number of equivalents of acid equal to number of equivalents of base. Okay, and into B, it is liter, means one is weight by equivalent weight. Sometimes one acid or base they will give normality and volume, and another substance they will give mass. In that case, you have to use this formula for titrations. Okay, and redox titrations case. Okay, so number of equivalents of oxidizing agent equal to number of equivalents of reducing agent, or N into V of one of the reagent is equal to weight by equivalent weight of other reagent. Maybe oxidizing agent, this one means it is a reducing agent. This is for redox titrations. Okay, so these are important concepts related to normality. Sometimes they use, they are asking related to what is the equivalent weight general. So by definition wise, how much weight displacing 1 gram of hydrogen or 8 grams of oxygen, 35.5 grams of chlorine is generally called as the equivalent mass. Okay, and for that one we use generally formula finding equivalent weight. W1 by W2 is equal to E1 by E2, or W1 by E1 equal to W2 by E2. This formula will be useful for finding the equivalent weight of elements and metals, right? Suppose oxygen case, weight of oxygen by weight of equivalent weight of oxygen is equal to weight of metal by equivalent weight of metal. Okay, so by doing this, commonly we know that equivalent weight of oxygen will be 8, equivalent weight of hydrogen will be 1, and equivalent weight of chlorine will be 35.5. So if one of the thing we know means other we can easily find out. Second one, if the equivalent weight of AB is equal to equivalent weight of A plus equivalent weight of B. This is also very important one. Okay, suppose equivalent weight of calcium carbonate is equal to equivalent weight of calcium 2 and equivalent weight of carbonate. Okay, so it is 40 by 2 plus 60 by 2. Okay, so like that it will becomes how much? 50 you will get. Directly you are finding salt, this is the 100 mass, valence vector 2. So magnitude of charge plus 2. So minus 2. So it will be 2. Okay. So like this we can able to find out. Okay. Another one, H2O2 related also they are asking sometimes. Okay. We will discuss here itself. H2O2 case, they give V volume H2O2. What is the meaning for V volume H2O2? Here, if I take 1 liter of H2O2, it will give V liter of oxygen at H2O2. That is the meaning for V volume H2O2. So, concentration of H2O2 expressed into V, okay, volume terms. So, V volume is 1 liter of H2O2 give V liter of O2 H2. Here, important formulas we can use. They will ask molarity means V by 11.2. If they are asking normality means V by 5.6. They are asking strength 17 V by 5.6. They are asking percentage strength 17 V by 56. These formulas will be useful for finding the which one concentration terms are strength or percentage strength related to H2O. Okay. And the next final one more one. This also degree of hardness. Degree of hardness also sometimes questions are asking. In this case, you can find DOH, weight of substance by molecular weight. This is related to solute, what we are using. And into 100 by weight of solvent, here generally water, into 10 power 6. Okay. If they given 500 ml, then you have to consider as a 500 grams. Okay. Since density of water is 1 gram per ml. Okay, and one more important point you have to keep in mind. Okay, what is the important point? Here, if they given 1 ml water, 1 ml water at STP, what is the difference between them? Okay, 1 ml water STP means this number of moles is equal 1 by 22,400. Okay, here 1 ml H2O, no information related to STP. In this case, number of moles is equal 1 ml equal to 1 gram you have to consider. Then number of moles is equal to 1 by 8. Okay, that is the huge difference between the water at STP and if not given STP. Okay, so these are the concentration terms. So in this video, what we have discussed: mole concept, percentage composition, empirical formula, molecular formula, stoichiometry and limiting reagent concept, and concentration terms. Okay, so just go through once in detail, note down the key points, and we will do the questions related to the concepts. Some good questions we'll do on this concept in a next video. Okay, thank you students.